I'll be presenting to you a topic that I hope will be as interesting to you as it is interesting to me. The topic is on semantic transfer in programming languages. Before we go any further, let me ask you a question. Have you ever made assumptions about the meaning of things? I believe we all have. We draw on past experiences to find patterns in how the world works. Assumptions are often quite useful, but that's not always the case. Assumptions are at the heart of transfer learning. Why should we care about programming language transfer? Students are faced with transferring from one language to the other in computing education. Most programming languages share similar underlying concepts. When you are learning your second programming language, it's quite different from when you are learning your first, because you're already familiar with some programming concepts. We therefore need to understand how transfer affects learning of second and subsequent programming languages. Researchers have reported transition challenges when learning new programming languages. Furthermore, prior work on transfer by Scholz and Weidenberg has identified that experienced programmers experience both positive and negative blend transfer when writing programs in a new language. To contribute to what others have done, we wanted to explore how transfer happens for relative novices through code comprehension activities. By doing so, we hope to help educators better account for success or failure of transfer. We used theories from both computer science and natural language acquisition to investigate the transfer process. The Mindshift theory by Armstrong and colleagues categorizes concepts encountered when learning new programming languages as carryover concepts. These are concepts a programmer is familiar with and they work the same way. And the other category is change concepts. These are concepts a programmer is familiar with and they work differently. And lastly, novel concepts, which are concepts a programmer is not familiar with. In order to explain Jan's theory of natural language transfer, let me give you an analogy. What do you think this French word means in English? Music. If you think it means music, you are correct. What about this French word? Report. If you think it means report, you are wrong. It actually means postponement. So what does this theory mean? It means that learners of new languages make word associations of the new language and the known language, and the meaning of the known language transfer into the new language. Now that we understand how people learn new languages based on semantic transfer, we wanted to explore this theory in the context of programming languages. Let's talk more about what we did. Our study was exploratory in nature, targeted at gaining deeper understanding into the transfer process. 5 students enrolled in an Introduction to Java course participated. They had 2 levels of prior knowledge. 4 of them had 1 year of procedural Python knowledge, and 1 of them was an experienced programmer with multiple language background and 6 years of experience. The research was conducted over a period of 10 weeks via 6 1-hour fortnightly individual interviews. Students carried out code comprehension activities. All discussions were recorded and transcribed by both authors. We found evidence of semantic transfer from Python to Java in the first session. This is whereby participants had not learned Java. How do we know it was transfer? When participants were reading the Java code, they showed how they assume meaning because of the syntax similarities they noticed between Java and Python. For example, in explaining line 4, participant 2 said, "It looks a bit like Python function. There are brackets that seem to be a parameter." And in explaining line 6, participant 2 said, "It looks like it's related to line 5. Like here, insert in brackets 12.4, maybe that's how you put arguments in a function." Students were seen to map methods, parameters, variables, and if conditionals to their prior knowledge and perceived them as carryover concepts, resulting in 4 out of 5 of them getting the Java output correct. In this case, semantic transfer was positive for learning. We see evidence of semantic transfer again in session 2 when participants had learned 2 weeks of Java. Consider the program fragment we used on the left, where they had to match Java program fragment to Python. Participant 3 said, "In Python, because you do not have to specify type, printing out A would print hello. If you need to assign the value A to a string, you need to write string A equals to hello. This is why I said the answer A is correct." Participant 3 assumed that because syntax differences are so small, the semantics are similar. In this case, they were wrong. The correct answer is C. Participant 3 had not assimilated the idea that types go deeper than syntax alone. More of these differences are explained in our paper. This is an example of semantic transfer affecting learning negatively. Lastly, we did not see evidence of semantic transfer on a perceived novel concept of Java objects. This was the case for relative novice participants in session 4. This session was conducted in week 6 of students learning Java. All 4 of the relative novices did not understand the concept well. This was not the case for the experienced programmer. This lack of semantic transfer was because they do not match the syntax of Java and Python to a common concept of data structures, because the syntax of Java is very abstract. Here are examples of how students explained their understanding of objects. Participant 4 said, "I think it's the most confusing part. I'm still not 100% sure what they are. I mean, our lecturer mentions objects sometimes, but I still don't get it." Participant 5, who was experienced, said, "I have no confusions with objects because I did them in C++. Participants were assisted through interventions to help them recognize that objects are not as novel as they thought, and that they correspond to a concrete data type implemented in Python using dictionaries and functions. Here is an example of a changed view about objects from participant 4. "I think now I see an object as an advanced way to store data and give you options to pass it around like lists and dictionaries, with techniques to manipulate the data. It's a lot simpler to understand objects than what I kind of did at first." The overall findings have shown us that without assistance, students will automatically transfer knowledge from prior languages, which can be good or bad for them. How then do we help students discover and refine their conceptual understanding in learning new languages? We suggest that educators should let students uncover the concepts and see the relationships between the known and new languages and enable transfer. The idea that the same syntax can mean different things can be reinforced and can be taken as an opportunity to teach deeper programming concepts. Where are we going with this research? Our long-term goal is to do further studies that will enable us to build a model of programming language transfer which will help us understand transfer. We believe this will inform pedagogy of second and subsequent programming languages. Thank you for your attention.